Okay, bismillahirrahmanirrahim. Assalamualaikum. Kita sambung balik kita punya uh, uh, pasal reinforced concrete column. Okay, so this part I will continue with the biaxial bending of short column. So in the previous video, I already explained on the axial load column and also column with the uni-axial bending moment. Okay, so so now I'm going to explain about the biaxial bending of short column. Okay, for most column, biaxial bending as shown in this figure will not govern the design. Okay, the loading pattern necessary to cause biaxial bending in a building internal and edge column will not usually cause a large moment in both directions. Okay, the corner column may have to resist the significant bending about both axes. Okay, just in order to ensure that the column is to be designed as a biaxial bending, we need to check the eccentricities condition. So there are two conditions here. If they satisfied these both conditions, so it will design as a biaxial bending. Okay. The appropriate method specify that a column subjected to an ultimate load, okay, ultimate load and moment mz and my in direction of zz and yy axis respectively may be designed for a single axis bending, but with an increased moment and subject to the following condition. Okay, so kita dah kira dia punya eccentricity tadi. Bila dah kira eccentricity, kita dah tahu okay, dia kena design, bila dia dah fulfill this condition, dia kena design as a biaxial bending. Okay, macam mana nak design dia? Dia kena design for a single axis bending. Okay, with an increased moment and subject to the following condition. Okay, there are dua condition. If mz over h prime is greater and equal to my over b prime, kita kena kira dia punya then the increased single axis moment is using this equation. Okay, however, if they are fulfill this condition, which is mz over h prime is less than my over b prime, so the design moment for single axis is by using this equation. Okay, so if mz over h prime is greater and equal than this part, so the axis design moment is in z. Okay, however, if mz is less than the my divided by b prime, so then the increased single axis moment is using the moment in y direction. Okay. Okay, so we already have two condition here, and mana condition yang fulfill, kita akan use the design moment. Okay, so dalam design moment kita ini, kita tengok ada nilai beta. Okay, so MOZ tak ada masalah, MY tak ada masalah, H prime, B prime pun tak ada masalah. Okay, so beta adalah coefficient. So coefficient ini adalah 1 minus this equation, NAD over B HFCK, or we can find it in this table. Okay, so we can find the value of beta here by using the value of this equation. Okay, okay, H prime and B prime, mana location dia? Okay, so H adalah ini, H prime adalah dia minus dia punya nilai D. Okay, sama juga dengan B. So B adalah ini, B prime adalah minus with the nilai D towards B. Okay, so ini adalah H prime, ini adalah nilai B prime. So, kita dah tahu nilai beta, so kita boleh substitute dalam equation yang mana kita guna untuk mencari the single axis design moment. So, kita tengok example. Okay, example 9.5. The column section as shown is to be designed to resist the ultimate axial load of 1200 kN plus moment MZ and MY. So MZ 75, MY is 80. So give the characteristic strength. FCK is 25, FYK is 500. So first of all, we need to find the value of B prime and also H prime. So H is 350. The H prime is 350 minus 70. So B prime is B minus this one. So B prime equal to 140, H prime is equal to 180. Okay. So we can check the biaxial bending by using this equation. So we get the value of eccentric in Z direction, eccentric in Y direction. So we can check which condition, these two conditions. Okay. So after we substitute the value, so we got, yes, fulfill the condition. So hence the column must be designed for the biaxial bending. Okay. So after that, so we already know that this column must be designed for the biaxial bending. Okay. So we need to find the value, okay, for which axis to be designed. Okay, so MZ over H nilainya ini, MY over P prime nilainya ini. Okay, so sekarang nilai MZ over H prime is less than MY over B prime. So we are using this equation. Okay. Alright. So we already fulfill this condition. So we are using this as a design moment for a single axis Y. Okay. So nak proceed dengan ini, we need to find the beta first. In order to find the beta, we need to find the value of this one. So from the table, this value, we got the beta 0.57. Okay. So by using this value, we substitute in this equation. So we get the increased single axis moment in Y direction is 116.6 kN. So by using this equation, we need to substitute in this equation. Okay, so we just substitute the equation. Okay, so tadi kita ada cakapkan the nilai D over 2, D2 over H is corresponding with the axis yang kita pilih. So axis yang kita pilih ni adalah Y axis. So Y axis H kita akan jadi nilai 300, B kita akan jadi nilai 350. Okay, so we got this value 0.15. So we got this value. So NDK BFC we got this value 0.46. So by using the design chart, so kita dah tahu kita pakai Y axis punya design moment. So kita dah tahu D2 dia adalah 60 and H dia adalah 300. So chart yang kita akan pakai adalah 0.2. Okay. So by using this chart, by using this chart 0.2, we already have the value for the moment here 0.15 and NDK BHF CK is 0.46. So we plot here and we got the value for AS FYK is 0.47. Okay, so by using this value, so we just substitute all this value here and we got this value. After we substitute B, H, FCK, FYK, then AS is equal to 2467 mm. So kita samalah by using this one, we refer the table that we already used. So we can provide the 4H32 bars. Okay. So for the next, okay, by using this table, so the value, the required value is 2467. So it will be after this one, and we choose to have 4 bar of H32 size. Okay, so we provide the 4 H32 bars. Okay, let's proceed with the example 9.6. Okay, the figure shows a frame of the building which are center column along the PQ are to be designed. The frames are 4 meters center, are braced against the lateral force and support following floor load. So dia dah bagi dah permanent action, variable action, cover, reinforcement, link dia bagi, FCK, FYK. So dia nak calculate the load, axial load on each floor. Calculate the moment at each column of PQ, along PQ. Design the reinforce for each column. Okay, so this is the view, okay, the front view and plan view. So dia nak design dekat kolom sini. First of all, first soalan dia adalah kita nak kena cari load dekat each floor. Okay, so by using this arrangement of criticals, kita dah describe dalam 9.4 punya section. So we can calculate the maximum ultimate load at each floor and also the minimum ultimate load. So the maximum is combination of these two. Okay, so the minimum is only taking the permanent load. Okay, so sebab dia mention tadi the frame are at 4 meter center, so kena darab dengan 4. Okay, 1.35 GK, 1.5 GK. So just substitute and you got this value for the maximum. Okay, then for the minimum, you just take into account the 1.375 times with 4. So this is the maximum, this is the minimum. Okay, then the column load is this times with the distance. This total distance is 10. Okay, so half of it here, column load, and this one, second floor, the ultimate load times with the distance. Okay, half of this area and half of this area. Okay, so the column weight is 1.35 times with the density and this area of the column and also the height of the column. So you get this one. And okay, calculate the load axial on each floor. Okay, yang kita dapat tadi adalah column loads dekat setiap floor. Tapi untuk kira design section, okay, load on the second floor column akan bawa roof floor plus the column weight. Okay, so ini adalah dia punya roof cut dan ini adalah column self weight. So dia akan carry the load on the second floor column. Okay, atas ni. Okay, load on the first floor column. Dia akan carry load on the floor on the second floor column plus second floor plus column weight. Okay. So, and last sekali load on the pier column. Pier column, bawah sekali. Load on the first floor plus first floor plus column. So, you guys need to find this one. You need to understand this one in order to